Welcome to Decoding Coding, integrating computer science in the classroom, everyone. My name is John Graham, and I'm the Elementary Digital Learning Specialist at the Maine Department of Education. And I'm sure we'll have many familiar faces on here looking at the registration list earlier. So I'm really excited as I feel like this is like the first actual PD that we've done this school year that we've had, anybody that has shown up for. So that's a great sign, I think. And I'll let Emma introduce herself and kick us off.
Awesome. Yes, I'm Emma Banks. I'm the Secondary Digital Learning Specialist and the Computer Science Specialist at the Department of Ed. And today we're going to be talking about integrating computer science into the classroom. So we put together just a little sequence and a summary of this session, which we will share the slides out with everyone as well. So don't worry about taking notes unless you just would like to, but we will absolutely share this out with you. But we're going to start with talking a little bit about just what is computer science education in this context, and then we'll share some pedagogy strategies, and then we have some strategies to kind of make computer science stick in the classroom, and then we have some really awesome examples from Maine classrooms, and then just a few resources that are worth reusing and bringing back with you. And John, next slide, thanks. Okay, so that just is a graphic of the sequence that we're going to go through. I'm going to start with the foundation to frame. So this is really focusing on what is computer science education. And we started with a quote that I think is really kind of central to this. So thinking about this idea that computers are not just it's not just a piece of tech, but it's both the paint and the paintbrush in what is computer science education, creating artists. So really looking at it in kind of an abstract way. And I really love this quote because I think it takes something that's often viewed as very opposite of computer science, which was the arts, and kind of ties them in together and shows the parallel there. So looking at computer science as a definition, and like thinking about an explanation for it, it's defined as contexts and spaces where students are able to engage in hands-on, real-world interaction with key math, science, and engineering principles. And that's, so in addition to coding, it also gives students the ability to be a producer in their digital economy and not just a consumer of what's around them. A central principle of computer science is computational thinking skills and practices, and the skills there are relevant to problem solving across many, if not all, disciplines and careers. So some of these skills are very central to problem solving and just kind of working through daily life, and that's such as breaking problems into smaller numbers so that you can look at the pieces of a problem in isolation, and then recognizing how those problems relate to ones that have already been solved and trying to find the correlations there. And then also setting aside details of a problem that are less important and really focusing on those aspects that are crucial to solving it. And then, of course, identifying and refining the steps that are needed to reach a solution. So maybe something didn't work, what are we going to do about it, and how are we going to move forward? And so that just kind of frames a really complex definition of what computer science education is, because it's often thought of as just coding or 3D printing and programming and things like that. And it's just so much more than that. So we really wanted to expand on that a little bit. So what are some of the computer science instructional approaches? Maybe you are doing one of these, or maybe you're interested in exploring one of them. So really what we focus on is this integrated approach. So this is something that is taught across multiple subject areas. There's not really a specific class, and outcomes are interwoven into the curriculum for that subject area or for the subject areas. Another model that we see is when computer science is taught as a special. So it's taught during part of the year, or it's often paired with technology or computer skills classes, and it's focused on CS-specific instruction most often. And then we also see AP or elective models. So these are often chosen and not required, and there's a baseline of knowledge there that's important to have before they get into it. And these are also often very technical and specific in nature. There are, of course, other models, but those are definitely the three most popular that we see. So this is just a graphic to put together some of the key computer science concepts. So this is absolutely not an exhaustive list by any means, but this is meant to show the scope of how broad and how specific computer science can be. So from computing systems, which involves devices, hardware and software, and troubleshooting those things, to the actual cultural and social impacts and the safety law and ethics behind the impacts of computing. And then there's also data analysis, collection and storage, as well as visualization and transformation of data, and then different inferences and models. And then there's, of course, the networks and internet and talking about cybersecurity. And then, of course, on the more conceptual or technical level there, you would have algorithms and programming. So algorithms can be just a sequence of steps and things like that, or it can get really complex into including math into different things and whatnot. So you also have in that area programming as well. So that's some of the coding and more technical things that you end up seeing. So this is a closer look at kind of looking at computer science skills and thinking about what are the surface level skills that really all persons should know, all students should learn these things, and what are the skills that maybe they don't need to know. They might want to know a little bit about it, but it's something that they can kind of choose to dig into more depending on their interests. So some of the surface skills that we have here are digital creation and production, pattern recognition and sequencing, problem decomposition, that's a big one, and algorithmic and computational thinking. So these are the skills, and there's, of course, many skill sets within these kind of high level topics here. But many of these are those surface level skills that all students should have some type of experience with, and that can really be integrated into just about any learning experience. And then you have your submersed skills that are more specific, like robotics and coding and 3D design and printing, programming, graphics, networks, computer architecture, and databases and data structures. And those are elements that students, might find interesting, or they might choose a specific course on, like the AP course or the special course. Those are usually less integrated into a classroom. They're more specific. And next, we are going to shift to pedagogy to practice, and I'm going to pass it off to John.
All right, so I think this is a really key area in looking at, I think, two approaches that we'll often see in relationship to kind of schools as they roll out computer science. So some considerations and ways to think and frame that. So consider constructivism. So if you're solving problems, getting students to really engage in like the problem-based learning experiences, which I was excited to see some people on here that are involved with Moose, because Moose definitely has an element of problem solving and project-based in there. All hands on deck, providing those hands-on learning opportunities. So computer science definitely provides some opportunities where you can really work with things physically. And for elementary kids, as we'll see in our examples, there are often kits and tools that you can use on one end. And then for older kids, it sometimes can be an actual building of a device. Make it real. So bringing in real world connections wherever possible. This is, works with any content area, and computer science is no exception. Consumer and creators. I think this is a real key one as well. So empowering students to become those creators in the digital world where they're actually making content to put out there and share with others. I think that's kind of an exciting element that can boost that engagement for students if they kind of realize they have those dual roles. I think that really can engage them in another way that we don't, always have the opportunity to do in other content areas. And then promoting those opportunities for real life connections, like we kind of said, and finding those is one thing, but the ability to actually like publish and own content and push it out and stuff like that. I mean, this is the YouTube generation. They're gonna, be all about getting that content out there in new and exciting ways. So the 4 C's, which hopefully all of you are familiar with: creativity, collaboration, critical thinking, and communication. Those all tie in with computer science really nicely. So the opportunities for students to express themselves and be creative, the ability to work with other students, so the collaboration piece, the communication, and I think bringing in empathy, design thinking, really thinking about what it is they're doing with whatever it is that they're creating, thinking about their audience and so forth. And then designing assignments and projects that get students to really think critically, I think is a key part as well. There's a lot of fun stuff, as we're going to talk about with computer science, but really want to try to push them to dig deeper and think deeper. Computational thinking. So these 4 parts, which we kind of talked about these as those surface level skills. So I'll let you read through those kind of descriptions there, but abstraction, algorithms, decomposition, and pattern recognition. I mean, those are pieces that cut across all grade levels and all, for all students. So definitely some excellent skills to be building here that build right into computer science. And then the C's of CS success. So yes, you see the 4 C's in there, but we have our new ones that we've added in. So the considering constructivism, consumer and creator, that duality, and then the computational thinking piece. So all kinds of great C words to be thinking about when you're thinking about computer science. All right, moving on to the next section, some strategies to share. So how are we going to make this really stick for students? So embracing the power of intentionality. So many computer science concepts are present in things that we do every day. Computer science really is all around us, and I think there's a great opportunity there. You can find the intersections where those things are happening naturally, organically. Students will kind of, buy into that in a way they might not if you're just kind of talking about computer science as this removed concept. So anytime you're able to make those connections and bring them in an intentional way is going to help students make stronger connections. Keeping it simple. So some of the most important computer science skills start from very simple concepts, which we've kind of said a few times, like with the computational thinking, all of those things, they're starting at the pre-K level. And we'll kind of cycle back through that as they go through their educational life. So computer science gives them a way to think in addition to a way of creating. So computer science can really enhance what it is that they would be doing already. And by engaging those students, it is really going to bridge, opportunities for them to build more upon computer science if that's something that they want to pursue in a professional way, in a personal kind of hobby way. But there's so many elements of computer science that just kind of fall into day-to-day life. Really is one of those opportunities for students to be engaging in all kinds of different ways. Model. So any opportunities that you can come across to model computer science thinking skills, a couple of examples there. Making it intentional by calling out the ways that you problem solve, think critically, create steps. So modeling those and really walking through the process for students, that breaking down of those processes, of those problems, is really going to help students better understand computer science and be able to, move forward and build a deeper knowledge. Mind of the medium. So this is kind of a place where sometimes we can slip into the cool stuff, as Em and I call it. So students are able to engage with all kinds of different mediums for computer science and, really all kinds of technology. So try to be really thoughtful about the medium that you're going to be introducing and bringing in with your students. I'm sure you guys all have if you've worked with students doing computer science before, I'm sure you have your favorite tools, your favorite programs or apps that you use. So you've probably used those once and had success, and you go back to those because they were successful. So it's definitely part of the process is to be thinking about what it's going to take for students to get at that first step, first using whatever the medium is that you're going to be working on, to having them get where you need them to be using that medium. And that medium, and I know it sounds like a very vague term, and it is because there's so much in there. But that medium that you pick and how well students can engage with it and learn it and be able to apply it is really going to impact their complete learning experience overall. So that's definitely an important part of it. So the concepts and cool stuff. So you really want to try to avoid getting too bogged down in the cool stuff, the toys and tech. And it can be challenging because, maybe something's purchased by a parent, by an administrator, and they say, oh, I found this robot, or I found this kit, or I went to this conference and got this thing. And you might feel kind of pressured to use that, but if it's not really going to fit with what you're doing, don't feel like you need to use that thing just because it's there, because it's cool. Really want to try to find the right fit. And it's always better to lean on the concepts, kind of your conceptual base, as opposed to, oh, I've got this cool thing, I've got to figure out how to use it. You're going to kind of run into some dead ends there if you use that approach. So keep it based in the concepts. So here are our 5 strategies to think about in terms of supporting computer science integration. And then we're going to move into examples. So you get to listen to me talk a little bit more because it's elementary that we're starting with. So these are some examples that we've collected from around the state. If you kind of going through this, if any of you are like, oh, I'd like to share something, Emma and I are always looking for examples, recent examples of how people are integrating computer science. So feel free to pass those along. We'd love to add this to future presentations because we're going to be doing the same one for CSTA coming up here in a few weeks. So this one is from Bridget Dumont and Heather Sanfacone at North Berwick Elementary. So they took the story of the 3 little pigs and then brought in different tools to kind of retell the story. And because it was a story that students were familiar with, it allowed them to work with the story, work with the tech, in this case, the Sphero robot, and, go at it in a different way. And I think it was, a really fun approach. So I think this is a nice example of, and this is a kindergarten classroom, of embedding computer science into what you're doing in a really fun and engaging way for students. Sequencing and programming in physical education. So when I went down to Blue Point Elementary School a couple of years ago for a Hour of Code event that they were having, the phys ed teacher was so excited to show me how she had been using a B-bot to help students think about this. I know in the one on the right-hand side, the sequence, because it was during the winter, of getting their clothes on, like thinking about what was the order that they were going in. That one they didn't use the B-bot, but that one was the one that really stuck with me because that's something that kids are doing all the time, and any of you that are elementary teachers, that is a big transition in the school year when kids need to start getting on their winter clothes to go outside, and you'll have some kids that struggle with the order of that. So I thought this was a really cool way that she brought in that computer science language into it. And then the Bbot one was, they were using it, programming the Bbot to go around the board in a certain order based on prompts that they had. So I thought, again, a really cool way in elementary phys ed, not necessarily a place that you'd expect a lot of computer science to be happening, but I think with the right connections and the right framework, I think it really shows you can bring in computer science anywhere. This one from Jen Stanbro at Skillin Elementary School. So this happening in a library. So they were using makey kits and Scratch to make kind of their own, to me, I always thought of it as like their own version of the operation game. So they had programmed, you can kind of see on the right there, that body that's upside down, they had the different parts. And as you touch different parts, different things happen with a Scratch. So all kinds of, parts and pieces to this. So they worked in groups, and third graders, I think it's very impressive, not just group work, but I think the ability to both work with Scratch, but also to work with the makey kits to do something that's kind of both hands-on and has the on-screen computer components as well. Kern Kelly, who's the tech integrator in RSU 19, worked with a fourth grade teacher to make kind of three-dimensional spaces, virtual spaces, using co-spaces. So a lot of kind of coding and setting stuff up there. And they had interactive elements within those different spaces that they set up. But because they were focusing on Maine studies, they focused on different Maine state parks. And I cannot remember the number that they had, but Kern, when he shared this with me, like looking through that list, it was amazing to see. In my head, I was just thinking like, I could see fourth graders doing a handful of state parks, but they did, it felt like all of them. It might not have been all of them, but it was a lot of them. So it was really an impressive library that they had built as a group. And this one I really like, from Lori Delaney at SAD 4. So she did this, I think, at a couple of her schools, but this one is at the Georgie Jack School, and it's coding models for, so those of you who know about dash and dot, those are dashes that they've built up floats on top of, so then they had to program them to go on a certain path. So I know that this was paired with Balloons Over Broadway, that book, if you've read that before. So I think a really fun aspect, and it looks like that picture there, she even brought in some green screen stuff, or maybe just stripped out the background. So a lot of fun technology stuff happening here. All right, and I will turn it over to Emma to talk about the middle school and high school examples.
Okay, yes, I was going to say, so secondary is inclusive of 6th to 12th grade here. So we've got a wide range of examples to show you for this section. So in this instance, students at Herman Middle School were using the Edison robots, which of course you could use various different types of robots, but in this instance, they used the Edison robots to learn about uniform motion and acceleration. So they would kind of use the computer and their instructions, and they would work on a solution and then test it out and see what happened. And this was contributed by Claire Cadell from Herman. And we all probably remember learning about the functions of the cell in school. And so I really loved this example of contributed by Lynn Hanna from Connors Emerson School in Bar Harbor. I also really love that this also has choice involved. So students were either using Scratch or the Arduino kits to demonstrate the jobs of the cell, either virtually or physically. So if they wanted that hands-on experience, they could work with the actual Arduino kits. And if they wanted to get some virtual experience and use Scratch, then they could create a digital version of it. And so I really loved this example because it included that student choice, as well as the different tech elements and the different computer science elements that are thoroughly integrated in this example.
Emma, I just want to add in because I talked with Lynn about this, and I know her favorite part about this with the Arduino kits was that kids were going home and like problem solving stuff, like solutions, and bringing it back to school the next day. And she was just like, I've never had something like that, happen in quite that way before. And she said that, I mean, as a teacher, that's just one of the sweet spots that you can get into once in a
Right.
blue moon.
Yes, that's awesome. Okay, this is another example I really love, contributed by Kern Kelly. And this is an example of high school students who were, they captured images of the Nokomis Trail and created interactive food webs that were then shared with younger students. So in this instance, you have high school students creating content for younger students to consume. And so I really love that trickle down effect that they have going. And we've linked a lot of these examples out when there are links to go with it. So once I drop in the slides, you'll have access to really check some of these examples out in detail if you'd like to. Geometry. So if you're a fan of geometry, then you will love this. And even if you're not a fan of geometry, you might love it. I really enjoyed this example, and I'm not a fan of geometry. So it was very hard for me. I think if I could have had a hands-on example like this would have been great. So I love this from Lewiston Middle School. They practice teamwork and collaboration in math and ELA classes by going through these coding roles and doing kind of coding with like a paper and pencil. So they have the different roles and the stages that you would go through. And then somebody will actually work to translate the written plan into code on the computer and execute the code. And then the third role will actually reset the robot and help to troubleshoot the code or to write more efficient code. And there's some key aspects of this that I think are really cool. And the goal here is to program the Q robot so that it will do what they're looking to have it do. It's like simple stories that they start out with, that the Q robot, that's why he has 3D printed moose antlers, because they were working on the story if you give a moose a muffin in this specific example. So very cool use of both 3D printing and robots. And I love that this example has students working in small groups where they change roles every single time they engage with this activity. So there's not ever one student who gets, they only do developer, they only do programmer, or only do engineer. Everyone has to play a role here. So this was a really great example contributed by Alicia Jalbert and Sarah Irish at Lewiston Middle School. 3D design. So most schools have a 3D printer. Some are using it well, some are in the closet. And there are some really great uses that can happen with 3D printers that really involve students engaging in that crucial problem solving experience. So in this instance, which we don't have who the contributor was for this, I'm not sure, was from Noble Middle School, and they're identifying a problem that they can solve with a 3D printed item, and then they're designing it, printing it, testing it, and then there are 3D printed solutions all over Noble Middle School now for various different tasks. I really like the iPad stand. I felt like that was a very apt use for a school. I could see them wanting to mass print a bunch of those for students. So some really cool designs in here. This is an example that involves outdoor and indoor. So you've got that unplugged and the plugged in experience, right? So middle school students use sensors and data loggers and Scratch to engage with a unit on ecology and learn more plate tectonics. So you've got them outside doing stuff, you've got them inside on the computer, and really correlating the two of those together. And this example was contributed by Marina Vander Eebe from the Maine Rise Center. They're doing all sorts of great middle school integration stuff there. AP Calculus and 3D models. Here's another instance where 3D printing has been taken and made extremely useful. So this is talking about calculating the volume of different shapes, looking at it. And so instead of just keeping it 2D, they've really gone 3D here and allowed students to really get that hands-on applied experience. And so this was contributed by Damian Sorensen from Nokomis High School. And another Nokomis High School example. So Nokomis did build a new high school. I still am not entirely sure on that one. And they wanted to
Yes, they have a new school.
Do they now? Thank you. I was like, that my knowledge on that is dated. And so they wanted to preserve the memory of the old school. And so they actually built a virtual tour to preserve the history within the school. And I thought that that was just such a great use of, again, that virtual reality experience and trying to create an archive as well. You know, this creates a really awesome archive for that school that they can hold on to for a long time. And they used CoSpaces for that as well. Okay, so that was our last example, and we're going to shift gears and move a little bit into just a few resources to bring back to your school. These are resources that some of you are likely very familiar with and others may not have seen before. So I'm just gonna really briefly go through some of these, and then we will open up for questions and things like that. So in this slide, you have resources for kind of getting started with computer science or for digging deeper into those like technical planning aspects of computer science. So we have the K-12 Computer Science Framework, which is a really fantastic comprehensive guide to computer science for the K-12 school system. So that's a really like systemic type of document. We also have the scope and sequence of essential computer science knowledge and skills. That is one of my favorite resources. It really breaks down the computer science essential skills and really kind of puts some language that's easy to use with them. Then of course we have the CSTA K-12 standards. Those are really great to reference if you're looking for crosswalk between your curriculum and computer science, different standards and things like that. Code.org is great for kind of resources for, say, maybe you're not ready to deliver an original computer science lesson, but you really want to expose your students to computer science. You can go on code.org and check out some resources that really don't require a lot of background knowledge to be able to deliver like activities and lessons with students. Then from Maine Math Science and Alliance, they did a program called I2I, Integrate to Innovate, focusing on K-8 computer science integration. And they came up with some really fantastic results from that. So I've linked that there as a resource to be able to check out. And then I've also included computer science in early childhood, which is kind of, it borders on article resource information about what it looks like to integrate computer science in early childhood. So, you know, pre-kindergarten, kindergarten, that type of level. And then an article I really love about how to help develop computational thinkers and really get students to always be thinking computationally. So I've kind of set these up as resources for advancing computer science. So if you already have maybe a little bit of information about computer science, or maybe you've already been teaching it or something like that, but you want to dig deeper or you want to get more connected. So I've got the Maine Computer Science Teachers Association. If you are not already a part of that organization and you have any interest in computer science, you should absolutely connect with them. Fantastic organization to be able to connect with other teachers who are interested in computer science as well. And lots of professional learning opportunities. They share lots of great stuff. We also have computer science fundamentals courses for K-5. So that's a resource focusing on kindergarten through 5th grade fundamental opportunities. And then CS for All, this is an initiative with plenty of resources that really talks about how computer science is for all and not just for people who are interested in tech. So that's a great place to look for ongoing initiatives and things that are coming up and things like that. Then we have Hour of Code, Family Code Night, and Beyond the Hour of Code. So maybe you've never done an Hour of Code or a Family Code Night, so you might want to start with one of those, but maybe you've done that and you're interested in moving, like how do we get from this to integrating it into the classroom or integrating it into school? And so the Beyond Hour of Code is a really great starting place for that. So if you are already integrating computer science in your classroom and you'd like to share what you are doing with other teachers, or maybe you know of a really great resource that was not listed on our 2 slides, please feel free to use this link or the QR code to share something via Padlet with us. As John mentioned, we're always looking for examples, and we will absolutely include them in our professional learning. So it will get shared with other teachers as well. If you have photos, that's a bonus. Photos are always appreciated for any type of visual component, of course. And at this point, I think that if anybody has any questions or thoughts that you want to share, we have a little bit of time that we could have a discussion. I'll stop the recording now.